Hello, good evening, everyone, or good morning, depending on where you are. So it has been quite a busy week. Let's wait for 1 or 2 minutes before we get started. And it is truly exciting in terms of AI integration with our daily lives. Some of you may have followed the news about the recent release of the Raymond Meta AI glasses. It seems to go viral. So I'll try to find some news about it. Ray-Ban smart glasses, Meta. Yeah, now it called for pre-order. And so it's a new type of smart glasses recently released by Meta, and it is a collaboration between Ray-Ban, which is a luxury glasses brand, and Meta. And they make a news release, and the smart glasses, you can talk to the glasses to basically ask anything for the glass, and the glass can actually have the same vision as you. So if you see something, maybe you see a French brand that you can pronounce, you can ask, and the glasses would be able to interpret the sign and probably pronounce it for you. It can take visual recordings and of course photos, and also you basically have the Llama 2 large language model to support any questions you may have. It doesn't have the visual capacity though, because the visual is definitely more difficult to embed in glasses. But consider the price line of $299 is only a small fraction of what the price line of the Apple Vision Pro, which is priced at $3,500. I think that glass had its niche, and also it's not invasive. So when you wear it, most people can't really tell it is regular glass or it is a smart glasses. Right? So it's not very invasive, and it's designed for daily use. Maybe later on I'll try. I'll probably wait for a while to see how others respond to the new thing, because most of the previous smart glasses fail miserably. Many companies design those smart glasses, but one famous example is the Google Glass, which priced at $1,500. And many years ago, I bought one, but I never wear it the second time. So yeah, it's just a complete failure. So a lot of experimentation. Many companies are moving into this field, but with little success. So we'll see whether the Meta newly designed glasses will bring us some good news. So yeah, a lot of other exciting things, but I don't want to talk too much, because today we are here to listen to Fan's talk on Metaflow, which is truly a remarkable interface or a platform for us to do end-to-end machine learning tasks. Okay, so let's get started. And any of you have any questions, anything you want to share before we get started? Okay. So yeah, Fan, the floor is all yours. Fan, you probably forget to unmute yourself.
Hello, can you hear me?
Yeah, we can hear you.
Okay. Hi, everyone. Thank you, Dr. Ann, for the great opportunity to explore Metaflow. So I'm excited to share a quick introduction about this open source framework called Metaflow. So Metaflow is the kind of like all-in-one, one-fits-all platform. So it has many components. So I hope this presentation would be like a good quick start for you, and I hope it can give you a basic idea of Metaflow. So we will cover the basic idea, what is Metaflow, why do we use Metaflow, the key features of Metaflow, and I'll provide a quick demo about like how to use it. So what is Metaflow? I wanted to start with a story of Netflix. So as many of you may know, Netflix is one of the biggest company that produces movies and TV shows in the world. In the past, Netflix has been really focusing on recommendation systems for over a decade. So when we log into Netflix.com, you will be able to see TV shows and movies that is recommended to you. That is a machine learning system, as many of us may know, that will produce user-specific recommendations based on our like viewing and comment histories. So let's see if I have watched the movie Zootopia on Netflix. So what happens next? It seems like Netflix knows my mind. It will recommend other things like Zootopia to me. So basically, they will recommend some like talking animals movies to me, or something about social justice. By understanding the viewing patterns and preferences, Netflix can make more informed decisions about like what recommendations can push to users and what types of original content to produce. Therefore, they can like generate a more tailored, targeted experience for diverse users. Actually, when Netflix started to produce their own TV shows and movies, things are getting more and more complicated than just recommending things. So therefore, there are actually a lot of opportunities for different machine learning and data science techniques to jump inside. For example, one team in Netflix might be interested in natural language processing. They would like to dig into the huge amount of textual content that Netflix has. They might be like analyzing the movie scripts, the reviews of customers, or even feedbacks and complaints. And then probably on the business side, there's another team in Netflix. They might have like a totally different perspective. Imagine they are trying to predict why some users continue to subscribe to Netflix and why some of them choose to cancel the subscription. So this kind of like process involves predictive models, and there are even more. So we just mentioned that Netflix started to like shoot their own movies. So think about like shooting a movie. We have a bunch of people. So we have like famous actors or crews. We have like different people and different devices. We want them to be at the same location at specific times. And these locations are not, they keep changing. So this is not just like mark it on your Google Calendar. It's like, it's a process of optimization. So the most important thing Netflix has is video content. So that's like that's a thing of computer vision. So we are thinking about like the characters or like the different views, or maybe even automating some part of the production process. So we talk about different techniques. We talk about NLP, we talk about computer vision, or like something else. Each project has their own set of challenges. They need different frameworks, or they need to deal with different sizes and types of data. And some of them are like at different stages of their developmental cycles. For example, there are some like techniques are very well developed, like NLP, but on other side, for example, computer vision, probably some of them are just at the experimental phase. So we are not sure if and how we can like play them together in the same company. So the big question for the like proposed platform is, what do all these diverse projects and people have in common? Is it possible to have like one single platform that we can meet all the needs of different techniques and different people? I mean, like there are some specialized platforms here. So if we work on deep learning, we have tools like TensorFlow. Like for NLP, we might be able to use like Spacey. So, but if we want to add something different in a different domain to our existing program, how can we like compose them together? So this is like a really, really big challenge, and that is also why we really need one like a platform that fits a one size fits all. And let's continue to think about the common things we have here. So we talk about the different techniques. Another thing is that like obviously all these things need, all these techniques, all these projects, they all need data. We know data scientists work with data. Data is like the key factor, the most important thing of data science project. And we should be easily to access data. However, in reality, data can be in different forms. It can be like tables. It can be like unstructured data, like text, like images. For example, if we work with NLP, the data type will be primarily text data. But if we work with computer vision, we will probably be working with images or videos. This can be like simply 2D image or like complex 3D structures or videos. So it's like getting more and more complicated. If we want to work with optimizing schedules, like what we mentioned for movie shooting, it can be like the data type can be like time series data, integers, or category data that can like provide information about data, about locations, about like time slots, about roles, different things like that. So that's something we can think of these projects and things in common, that they all need data. Another thing is all these projects and all these people, they all need to compute and process data. We are right here in the picture. So we all know that all the machine learning techniques we need to compute like pretty intensively. We do some like pretty intensively computing. So Netflix actually has been using AWS, which is Amazon Web Services. So AWS is kind of like a digital toolbox. It can like provide some computing power, so like Netflix can use. But for others, it's kind of like different projects are doing different things. So let's take computer vision as an example here. So we might get involved with data pre-processing, and we might like I put an image here to illustrate the process of doing like using kernel to fill the data, to like sharpen the data, something like that. Like if we do some churn prediction, we might need to like clean the data, pre-processing the data, and then train the data, and finally hopefully we can publish the result. However, like I mentioned that all the projects are different, all the computing are different. Actually they all share a common thread that we can abstract the process as a workflow. So even though like different techniques are doing the computing using different packages, but we can abstract them as like a workflow. So that's the base we can find to build a platform that can fit all of them. So that's another common thing we want to find. Another thing we want to consider is version control. So even though I'm not in the field, but
sorry, Fan, sorry to interrupt you. Are you still on the same slide, or have you changed the slide but we couldn't see?
I'm still on the same slide. This is
okay.
This is the biggest picture. I put like a lot of information here, but my drawing is not really good.
Yeah, no worries, no worries. I just want to confirm because I'm afraid that we are losing your slides. Yeah, you asked the same question. Yeah, go ahead.
Yeah, so like another thing we want to think about is version control. Like we all use like phone apps. We know like each app will go through a lot of like different versions. So that's something we really want to like think about when we work with machine learning projects, especially when we want to put some like what we work on to products. So another thing is like we have been using a lot of existing packages like scikit-learn and TensorFlow. So I remember when I was in undergraduate, we learned Java, C++. We actually started from like scratch. We write our own code. But as like the technology develops, we have like a lot of powerful packages and tools out here, so we can use them. But the problem is different projects have their different needs. Like for some, for NLP, we might use Spacy. Like for image recognitions, we might need like use PyTorch or something like that. So if we want to use existing packages across different projects, how can we manage them together? Another thing we want to think about is that like for all these packages, they are updating themselves all the time. So like they publish new versions, they release their new versions. If we are running a product like using the old version, so sometimes there might be some problems. So that this kind of like using existing packages, and the existing packages keep updating, add to the problem of like add to the challenges of having a one-fits-all platform. That I talked about like a lot of different complex and how difficult, how challenging it can be, but that's where Metaflow comes in. Metaflow is the goal. The goal of Metaflow is to create one single framework that can like tackle all the challenges I just mentioned in one coherent, user-friendly platform. So you might be really curious, what is Metaflow? So what is exactly Metaflow? Metaflow is a data science platform developed by Netflix, because like the story, they have like the specific needs to coordinating all different kind of people, all different kind of projects. So Metaflow is a data science platform that can make data science like usable, scalable, reproducible, and production ready. Metaflow is kind of like a unified form. So when we use Metaflow, we don't need to like as data scientists don't need to like think about the other tools. Instead, they can focus on what they do best. That is like working with data. And then Metaflow will take care of all the other things. So there are 4 goals Metaflow wants to achieve. The first one is like usability through structured workflows. So I mentioned workflows, even though different machine learning techniques, they have like different algorithms, and they work with different data, but we can abstract them as workflows. So the primary goal is to simplify the life of data scientists by using the API to structure the machine learning techniques as workflows. The second goal is to reproducibility with snapshots. So Metaflow addresses like the reproducibility by capturing the snapshots of data, codes, and the dependency of each step. So we will talk about this in detail later. It's pretty amazing. And the third goal is to like scale the product so it can go in the cloud. And the fourth goal is to record. We may know that like when we try to start our product, start our like machine learning project, we might start from our local like laptop, and then we will go in the cloud, and there will be like many rounds of iterations and like versionings. So how can we take good records of all these different versions, and how can we access them easily? So Metaflow can do a pretty good job about that. So here is like a picture. I try to illustrate that. Here is a data scientist. We can easily see his self-identification is data scientist, and we put that as orange. And here is like all the information we need when we try to all the process we need to go through when we need to like develop a product. So actually, we know these scientists, they are they focus on data, as we can see from their name, but they are less concerned about lower level tasks, they are they assume they just do what they are good at. They don't want to spend their time to do something they don't really good at it. So Metaflow can address these challenges faced by data scientists, from fundamental to complex. They can offer solutions for basic needs like data management, computing, scaling, and workflow execution, and both during the prototype phase and all the way to the production setting. And what is helpful about Metaflow is that it makes it easier to do teamwork. We will talk about in detail, but actually Metaflow can make us simply collaborating with large teams. It can join it can join the different results, different products from among different computers, laptops, and put them together. So that's pretty amazing. So we want to talk about why Metaflow. We actually talked a little bit why Metaflow, because it can help through it can work across different projects, across different versions, different techniques. But in this part, I would like to unpack what Metaflow can contribute from the perspective of project lifecycle. So we all know that the process from moving a project from prototype to the product is time consuming and very challenging. And Metaflow can be helpful in every phase of this process. So let's see, we are data scientists or machine learning engineering. We are developing something on our own laptop. No matter what kind of machine learning projects we are working on natural language processing or computer vision, our ultimate goal is to take what we have built and make it a product. So when we talk about production, we might feel a little bit confusing, because production might mean different things to different people. But here are some things I would say most people would not disagree. So the first point is that a product must needs to be really available and reliable. We don't want our products crash. At least we don't want the product crash a lot. It should run automatically. If we release a product and there needs someone to press the button every time to train a model, I think that's not a product. That's not a product ready thing. So another thing we want to think about is scalability. We want because when we work on our own laptop, we might only train our models with a little amount of data. But when we want to make it a production, we really want to make sure we can train them using a huge amount of data set. So sorry, my mouse is not working very smoothly. So here is a process of every step we want to go through from the prototype to a full production model. So like traditionally, people would think this is like a black and white situation. So we might start with step 1 and we jump to step 2, and then finally one day match play we have the production ready. But actually I would think this is kind of like a spectrum. It's like an iteration. So we might go through some part of this, and then we might go back and forth. So let's talk about this like in detail. So the first thing we want to talk about is cloud workstation. So usually the journey starts with our own laptop. We try to build a prototype at our own laptop, and but like as we are involving our understanding that the transition as we are evolving our understanding, I bet like a lot of people realize that using a cloud workstation might be easier. So when we talk software and class, we use Google Colab and something like that. And we can start with cloud workstation. Here is a picture I derived from outerbound.com. Outerbound.com is a startup company that fully support Metaflow. Actually, it's the developer of Metaflow. They started this company. So we understand that it's easier to work with our local laptop, but sometimes at Netflix, people are using what I just mentioned, AWS, Amazon Web Services. The reason why do they need that? It's like because when we are thinking from the perspective from our local laptop to the production environment is usually in the cloud. But if we start with our local computer, when we move to the actual production process, we will go through a lot of different things. Another thing I encountered that is I try to deploy Metaflow in my local laptop, and I think it might be because of the version or something. I posted on the community to ask why it doesn't work. Somebody brought up that about the different operation systems. So for my computer, it's Windows, but for a lot of production environment, it's Linux. So a lot of things would not be able to run on Windows. So if we can start at the very first step to go through the web-based environment, that would make the later work more a little bit easier. Sorry. Okay, so notebooks. We all kind of work, many of us have some basic information about notebooks. So we worked, for me personally, I have been using, I used Jupyter Notebook. So they are very good tools to explore machine learning projects or like we can deal with data sets, or we can like test out APIs, or we can build some small scale models. It's very powerful, like when we are trying to visualizing things. But sometimes notebooks have their like limitations, because like sometimes it's hard for them to maintain clean and production ready codes. We all know that like we need to go through multiple iterations for the production. So sometimes we might for example, for one variable, we might like change it so many times, it can like not maintain clean. So just like a quick dirty example. So it's very challenging to use a notebook to go all the way through the production process. So when we think about like if notebooks are not ideal for production level tasks, what can we use? That's why we want to have Metaflow, because Metaflow can like help with that, and I'll show you how it will do that in the demo. So create a workflow. Metaflow is designed to be approachable. If you can write code in a notebook, you will find it's very easy to create a Metaflow workflow as well. So I am totally new to Metaflow as well, but I don't see it's hard to understand what Metaflow, the codes, the basic concepts in Metaflow, because it's like very I think it's very user friendly. So I'll provide a basic example of workflow. So here is a quick example. So the difference from like the codes we usually write is it starts with the idea of nodes. It has like a start node and an end node. All you need to do is you decide what to write like between the nodes. Each node is like the method in your code. We can connect the nodes using this command, self.net. Basically, it's telling us which step we are going. So here we are going to the end. We are going to end here. So this is like a very basic and simple flow we can use as a quick understanding. But the point here is that it's very clear. It's really helpful to visualizing the process. And when we do the demo, we can see actually the sandbox can provide some visualization for us. That's very good.
So fine. Just a quick question. If you in the previous slide, just to help us understand. So we have is the start and end the required the required function, and you can add anything in between, right? But you have to have a start and end. Is that right?
Yeah, you can add multiple things in between, and we'll talk about like different structures. It can be linear, it can be parallel, and we can like join them together. But this is like the basic starting point. You will have to have these two nodes, and you can like go wild in between.
Okay, great, thank you.
And then we will talk about versioning, because we find it's like after we took a quick look at the code structure, we found it's pretty straightforward. But Metaflow is not just about the code we write; it's also about like it can like automatically snapshot. It's like automatically record everything. So the first thing Metaflow automatically stores are the codes. Metaflow put the snapshots on the server. So this feature is like particularly useful when we are like doing like some intense prototyping, because we will be making a lot of changes. We will be like going back and forth. If we can like do this automatically versioning and like recording, that would be very easy for us to find like something we did before. Like the traditional way to do that is like we manually do that on Git. But like Metaflow, for Metaflow, we don't need to manually do that. Metaflow can automatically snapshot our code for us. In addition to snapping shots the code, Metaflow also snapshots the internal state of the workflow. So by using the term internal state of the workflow, we mean that sometimes we might the values of the variables or parameters at certain steps, it might change at different stages, but like it can automatically record all of this at all times, or it can log some error messages and something like that. Actually, it's like pretty handy if we can like if Metaflow can help us logging all the error information. It's really helpful for us when we are doing like debugging. So if something goes wrong, we can easily go back and investigate the state of the workflow at the time of failure. So we'll see it's like very easily, it could be easily done by just adding a command. So we talked about like the local thing. Now we are thinking about like how to scale virtually, how we can use the power, the computing power. Imagine we are like creating a workflow. It works well like with a small data set. But what happens if we want to scale up? Maybe because our model is more demanding, or we want more like computing resources like GPUs. So for Metaflow, it's very simple. You just add a command, like you just add resources, you put the specific storage you want to use. That's all you need to do. And when you run this file in the terminal command, you just add a little thing like with batch. That's all you need to do. So it's very like quick and easy. So we talk about how to scale using the computing power. Another thing we want to think about is we are going to another dimension. So what if we encounter a problem that cannot be handled by just one single machine? How can we use the power of multiple machines? So these cases are actually pretty like often in reality. So in this situation, we can like Metaflow can help using the concept of horizontal scalability, which actually means that using multiple computers instead of just using one. Metaflow makes this process pretty straightforward. All you need to do is to add a list, and you can you can customize how many items you want, and then you simply pass it to the next function. So Metaflow will automatically launch the instances for us. We can control how many instances we want, and the process is pretty simple. And when we go to the sandbox, I can show you a quick, easy example of doing this. But the basic idea is that they are using parallels. They are using parallels to among different machines, and they at the end they are using a join command. But the join command doesn't have to name join, but they are join all the inputs together. So how can we access data quickly? So when the next challenge we might encounter in reality is that how to handle parallel data access when running when running our programs at scale. So for example, if we have 100 containers operating at the same time in the cloud, if all of these containers try to access the data from the same data warehouse at the same time, it can be really overwhelming. So it can cause to denial of service because of the overwhelming of the database. That's something we don't really want to see. So Metaflow actually provide a better approach for data access. So one effect pattern involves data engineering practice along data science of machine learning. In many organizations, they use Spark to manage the extract, transform, and load pipelines through SQL queries. This produces a source table, and which can be the input for the other machine learning projects. This is very relevant for when we are doing some relational data. And for Metaflow, they actually use Parquet. So basically, originally we try to store our data based on the role-based storage layout. Look here, if you have different roles, you put roles together, A1 2020 01 here, and you continue with another role. But for Parquet, they are going with the columns storage layout. So basically, it's going vertically like this. So this way, it's more reliable and scalable. So we can access instance in parallel without worrying about overwhelming the database. So this is the techniques Metaflow use to make sure we can access our data more reliable and without cracking the data set. Here is some skilled execution. So this is very simple. Again, it's just like a command. You don't even have to change your the code file in your terminal command. You just add two words functions created. So you can schedule your schedule your execution. Another thing we really want to talk about is phrase dependencies. So when we tried our very best across all the processes, but like occasionally there are still failures because of external dependencies, such as like TensorFlow. So this software packages, actually they are updating and they are evolving over time. This kind of like updating and evolving actually lead to change in their API, and sometimes they can break existing workflows. So if we what we were talking about were TensorFlow, that's like something already like pretty well developed. If we want to use something new, something like more experimental packages, things could be even worse. So with that being said, is like we tried our best to try to make our process more reliable, but there are some like outside variables we cannot control. So what we need to do is to isolate our production environment away from this kind of like unpredictable outside change. So like right now, companies have been like using Docker. They try to use Docker to create a stable environment. Docker is a platform that allows you to like develop, ship, run application in containers. So a container is actually a packaged version of an application with everything it needs to run, including the code, libraries, and the system tools. By using like putting the program in a container, this kind of like help the application to run the same way across different platforms or different computers. So we can like either manually write Docker files, or we can use a centralized Docker image for everyone. However, Docker is kind of like one size fits all image, but it doesn't really fit different projects when we are having like very diverse needs. For example, like one project may need the latest version of TensorFlow, while like another version might need an old, another project might need an older version. So that would be beyond the ability of Docker. So Metaflow uses a different way. It uses Conda decoder. So if you know Conda, it's like a package manager, and it actually creates a virtual environment for our codes, and it manages all the libraries we are using. So Metaflow automates this process. We don't need to like install Conda or like call Conda. Metaflow make it like automatically. So next, like we are like approaching to the finishing line. Another thing is, if we already finished all the things before, can we confidently say that we can we are ready to upgrade something like a production, especially for something very powerful like Netflix recommendation systems or like ChatGPT? Can we do that? So usually people have been really, really careful. So what the smartest companies do is that they run A/B tests. So basically, rather than just like launching or releasing a totally new version of the product, they run multiple versions in parallel. Think about like ChatGPT, they release different versions to different people. Like certain people can have access, like have a little bit more access to like more content. So actually, this allows them to compare the results and like maybe expose a little bit more newer version to a limited subset of users. If something goes wrong, the impact is like minimized. So Metaflow can help with this as well. So here we can define projects and like so that's actually a way to group together multiple related workflows. So imagine you have one workflow for training a model, another one for making like predictions based on the model. Let's still take Netflix as an example. Let's use their like recommendation system. So one task would be use the system to like suggest movie, like to predict what kind of movie people like. Another example, another task is to use the system to suggest the recommended movies to people. So the first one is to make prediction, and the second one is push the prediction to people. So Metaflow will allow us to link these two tasks in one group, and this group will be called a project. So when the first task finished, building the recommendation system, the second task will automatically start to work. It will start to suggesting movies and TV shows to people. This way, like everything works together smoothly without we like trying to start each task manually, trying to stack them together. This kind of like process also makes it easier for us to try out new ideas safely. Like for example, we can test out a new way of making TV, like movie suggestions while we can still keep running our old model. Especially, we can compare between these two and try to identify which one works better. This is like really useful when we don't want to like mess up our existing system and still trying out something new. So we have go through the whole process from prototyping to the product, and we reviewed like every step how Metaflow can work. Actually, along the way, it's like really hard to keep different versions of our experiments and workflow, and we can as our needs grow, we can like scale our resources vertically and horizontally, and we can try to figure out like Metaflow can help us to quickly assess data, and also they can help us to create a stable execution environment by like creating a virtual environment and freezing dependencies. And at last, A/B tests allow us to safely experiment with different versions of our project without like impacting the existing ones. However, even though we tried everything, but still things can go wrong. Everything from our model like can go wrong. That's why we were like adding this part, debug here. So I briefly mentioned that Metaflow can help with debug pretty easily. So when we see an error, we need to go back to our development environment to do troubleshooting and try to improve our models. So Metaflow provide failures to include our code's robustness. So here are two commands you want to try. The first one is retry. Actually, you can like specify how many times you want the model to retry. So here I put 5. So it can try it up to 5 times in case there is like a failure. So catch is a command it can help you to log the failure and try to handle the failure. Or we can like see that in the demo. So we have a basic idea of what is Metaflow, like how Metaflow can play in the whole process from scratch to the product. So I want to like talk a little bit about the basic concept in Metaflow. So the first thing we want to talk about is direct graph of operations. So at the very beginning, when we were talking about the story of Netflix, we were saying that different machine learning techniques are really different, but we can abstract them to like a flow. So that's this kind of concept. It's like a directed graph of operations. It's a set of nodes connected by edges, like where each edge has a direction. So in Metaflow, this graph represents your flow and can be very good to like represent your data processing pipeline. So it's a good fit for machine learning workflows. Flow, it's like the direct graph of operations that your program will perform. It comprises steps, which are nodes, like what Dr. Ann just mentioned, start, end, and like the and transitions. That's the edge connecting these nodes. So steps are the operations in your flow. So in Metaflow, it's like a step is actually a unit of operation you want to define. For example, if you are building a machine learning model, you might have steps for data loading or like data data loading or data pre-processing, or we can have like steps to train the model and like evaluate the model, different types of steps like that. So it's like a different Python functions. We can use decorator. We can use a step decorator. So run is like we try to run the flow. It will go through the structure of the flow and try to like from the top to the bottom. Another unique concept is the structure of the transition. So we mentioned that between start and end, we can do whatever we want to do in the middle. So the basic one is a linear transition. So it goes from start to A and from A to end. Here is a basic code. We can like get a basic idea. So it's actually a blank one. We start with a start node, and at start we let the system, we let the program print starting linear follow a flow, and then we use self.net to tell them to tell the flow the next step would be here, and then the end self is actually a function. In this function, it just print like some string saying linear flow finished. a pretty unique concept in Metaflow is artifacts. So what is artifacts? Artifacts are data and objects that we can produce within our workflow steps. I think it an easy way to remember to understand it is like it's a temporary variable. So it can be anything from data file, it can be automatically tracked by Metaflow. It's very convenient to manage your data as it moves through different parts of your Metaflow. So here in the graph, we start with the beginning, and then we create artifact called my variable, and in the node in the middle, you can use it or you can modify it, and then at the very end you still have it. It's stored. So here is an example. We actually created a artifact called greeting. So at the very first step, we assign value, string value, hello Metaflow to greetings, and the middle step, look here, self.next, self.modify. So the next step would be here. So in modify function, we just change this to make it longer. Change it to how are you today? And then at the very end, we are printing the final message of self.greeting. So we talk about linear transitions. Another structure is branches. It's very easy to understand. You start with from the very beginning, the start node, and then it can go parallel and it can go multiple ones. It doesn't have to be two parallels. It can be multiple ones, and then you join them together, and then it comes to the end. Here is the code example. So we here is a start. Here is a start node, and we have self.a and self.b. So this command, this line actually means that after we go through start, we will go to self.a and self.b at the same time. And after we go to them, run them at the same time, we will join them together, just like this one shows. They will go to both A and B together, and they will join together. So card is another thing that's pretty unique to Metaflow. So basically, it's like a user interface component that will help us to visualize our data and results easily. So in the demo, we will be able to see one example of a card. So it's basically, I think it's something you can just conceptualize as something that will help you to visualize things. And another thing is that cards can be shared. You can send them to your team members, or you can save it for future use. Okay, so we are going to the demo phase. I actually tried several interpreting environment. I started with Google Colab. So here is a very basic code. It's called, I think it's, Hello World. That's like the first one we typically have. So it's pretty simple. We install Metaflow, and then we like install the upgrade Metaflow to make sure when there's update, our like Metaflow is always stay up to latest version. And then I had a very hard time trying to run this code because I realized that Metaflow is Google Colab might not be a good choice to run Metaflow because like Metaflow's internal working rely on the file contribution, but like for that attribute doesn't really exist in Google Colab. So what I did here was I wrote the file. I wrote the whole flow into a file and then execute the file within Google Colab. And there are other reasons why I don't think Google Colab could be a good place to run a Metaflow. One reason is the time limit. We know like Google Colab sessions have like a lifetime, so it's very easily for a Metaflow to like run out of time because like many of them are like they run very long time. And another thing why I think Google Colab is not a good option is that Metaflow has like some built-in tools for versioning and managing dependencies, like what we mentioned, how to freeze the outsider dependencies, but that's not fully compatible with Google Colab. And for the task scheduling, there are some functions that's not fully supported in Google Colab. So that's why I just run the very basic one in Google Colab, but didn't really go further. I also tried VS Code, Visual Studio Code. That's my I was totally new to Visual Studio Code. I had a hard time trying to install Metaflow. Still right now, I'm still trying to figure out what's the reason. I asked different people. I actually posted on their Slack. There's a website called Slack. I put that website in my slides. It's pretty helpful. The developer of Metaflow, he is pretty active on that website. He replied to my my questions, but still didn't figure it out yet. So hopefully I can figure out how to do that. My guess is like one possibility could be my Python version could be too old. Another guess is somebody says like it's probably because of the operation system, the Windows and Linux thing. I'm not quite sure about that. But
yeah, so maybe find later on you can try Anaconda. So Anaconda support Python natively, and you can create a virtual environment very easily in the Anaconda environment. So you can download Anaconda, and then you can open an IDE running Python in a virtual environment, and you can use, for example, a Jupyter notebook. And because this virtual environment the environment will be the same, very possibly the same as a Linux system environment. So I think that possibly could run Metaflow better. Although, well, I'm completely new to Metaflow. I've never used that before. But it seems like if the Metaflow natively support notebook, including Jupyter Notebook or Jupyter Lab, then Anaconda, if you want to run Jupyter Notebook in your personal environment, Anaconda probably is the best option. It's definitely, I would say, better than Visual Studio Code, which support Python, but not to the extent that Anaconda does.
Okay. Yeah, the reason why I choose Visual Studio Code is the official like the demo we will be playing by Metaflow. They use Visual Studio Code. I actually tried to create the virtual environment in Visual Studio, but somehow it still doesn't work. So that's something like really confusing to me.
Okay. Yeah, that is challenging. No, I tried it myself. No, because I'm also using Windows system, and I create a virtual environment that you can actually run Linux system. So it took me probably 2 days to build that. Yeah, there were a lot of issues here and there because Windows unfortunately operate very differently than Linux system. So you probably have to build a virtual environment first before you can run Visual Studio.
Okay. So after having all these problems, trying to run Metaflow, I eventually go to their official place, which is called Sandbox. The Sandbox is an environment designed for testing Metaflow in data science applications. It's a safe place to do experiments, to learn, to understand, and like it has like very useful tutorials and examples, and it helps us to understand the basic concepts we just talked about, like the cards. It's like abstract when we talk about it, but when you see it, it's pretty easy to understand. So here is the website. So Sandbox is not in the website of Metaflow. It's in Outer Bounds. It's like another startup company actually developed by the developer of Metaflow. So if you can Google Metaflow Sandbox, or you can just type in this website. And one thing you want to know is that the limit of having a sandbox is 7 days. So if you want something back, you may like contact them to request things. But like if you are just like exploring, so you can just like open your sandbox. If it says your sandbox has expired, you can just simply request another one. So here is my sandbox. This one is built based on Visual Studio. It's a little bit slow. Okay. So here is the basic. Here is a basic example. It's like a basic one. You don't need to like change anything. You can just run flow to have a basic idea. The layout is like exactly the same. It checks the graph for us. It says graph looks good, and it gives us the different tasks. And one cool thing about this is it gives us the user interface. It actually created a dashboard for us so we can visualize the process. I was running something today, so you can see them. I didn't turn down my computer, so here is a flow I just ran. If you check here, if this little dot like line is green, it means it's completed. So when it's yellow, it's running. When it's red, it's failed. You can click inside. You can actually see how long it runs, and you can see the like. That's why that's like the you can like see the structure of the codes. Here is like we start, this is the parallel one, the branches one. So it starts with start, and it branches to two parallels, eat and drink, and then they join together, and then they end at the like at the bottom. All reflected, so we can see the process of running. Again. You can also go into the details of the tasks. You can see the standard output, standard arrow. And let's see. Let's take a look at the parallel process. Or since we are almost running out of time, we can go to like the production ready environment. This actually takes a little bit of time to like, it wants to make sure the condo environment is like configured as what we set in the code. But after we finish up, changing the process could be pretty quick. And let's see, while it's loading, you can see here, you can see the green, like the yellow one showing it's running. We can see it running in real time. After we finish this, when we click on visualization, visualize, we can see the card generated by the codes. This code is like I think it's the lights during night of New York City. It defines the lights like during 1 week, Monday through Sunday. So you can like click on this and see the card, the like visualization of the lights across during the whole week. And you can share and like save the card. Yeah, it's finished. See, like here we can see the cards. Here is the like image data of New York. The I don't know what day is it, but that's like the light of New York on that specific day. And you can like click on different days and visualize it. It's a little bit slow when it comes to the visualization, but the basic idea is like in the sandbox, you can like explore basically everything. You can explore the basic structures of the flow. You can explore how to scale it out to the cloud. Basically, it just use different commands. We mentioned like it use this one. That's another like command we can use to request like computing spaces. And here is the size of the memory. And also you can like do some machine learning in action things. But the basic idea is that like Metaflow can get involved in the whole process of machine learning from the scratch to the full product, and it's very easy to use after you can figure out the environment. Yeah, that's it for the basic introduction of Metaflow.
Yeah, this is fantastic fun. It's very informative, and probably none of us have ever used Metaflow before, but it seems like the process is very easy to understand because it's just use the DAG graph to make it very clearly organized, and also expandable both horizontally and vertically. So, and also it has the capacity, I guess it has, maybe so it's probably signed some agreement with the AWS, so we can request additional computational power. And that is important because most likely when we develop our computer vision models or NLP models, is going to be computationally very heavy. So we do need GPU, we need probably large memory, and maybe sometimes even multiple machines. And yeah, it would be quite cumbersome for us to develop everything in your own computer and then try to use Docker. I used Docker previously quite extensively, and I found it's very time consuming to use Docker because usually you need multiple packages from here and there, and you want to build a Docker that can resolve all the dependency problems. Sometimes it's a nightmare. And also download the Docker itself sometimes take minutes, probably 5 to 10 minutes if the Docker is big. And every time if you use the system, you have to download the Docker again. So definitely, I would say, yeah, this is much better than Docker. If it claims what it can do, it just use the Anaconda to fix all the dependencies. If it's as easy as that, then I would say it's definitely much better than using the Docker. Here you also showcases that you could expand the machine vertically, horizontally, and also doing parallel computation. I don't know exactly what the function they use to join. I know probably we later on we should think about how we could use multiple GPUs to do computation, whether it can truly, for example, calculating the gradient descent, calculating the gradient in some fashion horizontally, and then join them together, for example, taking the average. Then it's definitely going to speed up the training, because really the bottleneck is the gradient calculation and updating the parameters, because the next gradient, the next update of the parameter is based upon the previous gradient. So if we can do that in a parallel fashion, for example, one machine dealing with 100 batches, another machine dealing with another 100 batches, and combine them together, you join the function. Yeah, that's definitely going to speed up the training process. So yeah, overall, I think it's really fascinating. I want to try this out myself. I'll try with my Anaconda environment to see whether I can successfully use Metaflow in my in my virtual environment, maybe using a Jupyter Notebook or Jupyter Lab. Some of you may have already used Mac, so it's naturally supported for Metaflow, as Bob mentioned. If you are using Linux system, that's also fantastic. But anyway, yeah, I would say, yeah, this is really interesting. Thank you, Fan, for taking your time to delve into this Metaflow. It's definitely not easy for you. It's not easy for anyone. And you got sick for a long time. So really, we appreciate your efforts putting into this presentation. This really informative. For next in 2 weeks, we are going to invite Chen to come, and I asked her to explore a very important domain in machine learning and deep learning, which either of us, to some extent, are going to find useful, which is about labeling. No matter what architecture you build, you have to use data, right? And most likely we have to hand annotate the data. Though there are text data sets, there are image data sets, and many other different data sets. So I asked Chen to do a comprehensive review of the existing and most popular annotation or labeling tools for text data. And later on, I probably would ask one of you to explore the auto labeling or hand labeling of image data as well, so that later on when we build our own model, we will know what are the tools that can annotate the data more efficiently with a lower price, etc. So the data labeling is always a labor-intensive work, and mostly can only be handled by human being by definition. Because if we can automate that process, then we don't need to label at all, right? If you can use machine to reliably label that, then there's no reason for us to hand label. But there's still a long way to go. Okay, so. Shambabi asked, does that also work for working in Google Colab? I guess Fan's answer is it may not work well for Google Colab because of the various dependencies. And also, I don't think Metaflow natively support Google Colab because it's built for local environment and the scaling up using the AWS services. And you know that the AWS and Google Cloud and Azure, those are competitors, right? So they have different systems. Unlikely you are going to run the code error-free using Google Colab, but you could also try. There might be some tutorials. Some people may figure it out and post something on the on some websites that allow you to try out Metaflow in Google Colab. But here and there, probably you are going to face some issues. Okay, so any questions, any comments before we end today's meeting? Okay, and again, thank you, Fan, for your fantastic presentation. We all owe you a big thank you for your efforts putting into this. And thank you everyone for coming. We will see each other in 2 weeks. Bye, everyone.
Thank you.
Thank you. Bye.
Thank you.